Okay, we're still in chemistry. In this class of inorganic chemistry, we're going to talk about ions. We're still preparing and organizing ourselves on how to tackle elements and radicals. Yes, the basic ones are the main point we started treating. So today we're talking about ions. So when you come to ions in inorganic compounds, in chemistry, we have two major types of ions. We have cationic, or sorry, let me call it cations and anions, or let me say two main types, which are positive ions and negative ions, or metallic ions and non-metallic ions. These are the two major types of ions we have. Good. We now define ions are the charges that elements possess when they are in their ionic form. When an element is written in its ionic form, or a radical is written in its ionic form, good, we call them that they are in their ionic form if they have either positive or negative charges. So we now say that they are in their ionic form. That is what we define here. Good. Types of ion. The two main types of ion are: one, positive ions; two, negative ions. Then when you come to positive ions, we have, these are also called metallic ions or cations. They are the elements that possess positive charge in their ionic form. So positive ions are the elements that possess positive charges, that is plus, in their power, in the ionic form. We now call them positive ions. Examples of such ions are, we have calcium ion, sodium ion. Calcium ion has Ca2+. You see what I told us in our last class? When you are writing the charges of an ionic element, an ion, either metallic element or non-metallic element or radical, the sign, like this one, were in metallic radicals which possess all true positive, then the plus sign will come at the back. But if we are to just write the oxidation state of calcium ion, it should now be +2 instead of 2 plus. Good. When you come to this one, have sodium ion, which is Na+. It has valency of 1, that is the oxidation state of +1. But the 1 will not appear because we don't write 1 and the sign when they are accompanying the ion. Or if you have a 1x, you don't write 1 and x, you write x, but what is there is 1x. Then this one is magnesium ion, which is Mg2+, aluminum ion, which is Al3+. That is, 3 is the valency of aluminum. What I'm just using to write them are their valencies, but they are now in their oxidation state. That's why we're putting plus or minus, though minus will come in the case of negative ion. So the valency of aluminum is 3. So in its oxidation state, it will now be 3+. Good. Potassium ion, which is K+. Zinc ion, which is Zn2+. Barium ion, which is Ba2+. Silver ion, which is Ag+. Remember that the ones that have valency of 1, then if it is positive ion, you use plus only. Then the ones that have valency of 2, you now have 2+ when they are writing them. The ones that have valency of 3, you now have 3+ in terms of positive ions. Then we have more. Look at this one. Ion 2 ion, Fe2+. Ion 3 ion, Fe3+. Copper 1 ion, Cu+. Copper 2 ion, Cu2+. Mercury 1 ion, Hg+. Mercury 2 ion, Hg2+. Lead 2 ion, Pb2+. Manganese 2 ion, Mn2+. chromium 3 ion Cr3 plus, ammonium ion NH4 plus. Looking at this in our last class, I told us there are some elements that if you want to make use of them in compounds, you must mention the valency they use in that compound. Like here, in the ionic form,